if I go to Prismatic 3D and pick here, and I just measure this cylinder, and then I'm not going to do anything else except change its its probing method to helical scan, and then simulate that, then you can see that the head rotates. If you don't have your probe set up as a Revo probe, then you'll get a 3-axis scan. So that's cylinder. Typically you do a helical scan, arc scan, if I show you what that looks like. Simulate the probe path. So again, it wiggles the head, but it's doing it in 2 separate arcs. By creating a surface measurement, I'm going to do the face, so it measured a trim. Okay, that point spacing. Now, when you see this point spacing and you're saying, oh, it's cutting the curve, keep in mind, when this is run on the CMM, there's material there. It'll typically find its way around the curve. Okay, it won't tell the CMM to drive straight between there and there. But yes, you may want to have more points. So where does that point spacing come from? It comes from the checkmate parameters spacing. Right now it's set to 5 millimeters. I'm going to turn that down to 2. And I'm still set up as flow line. Oops, and I did it again. Pick down far enough, and now I get a 2 millimeter spacing. And let me get rid of that trim. Oops. Just hitting Shift Delete. So if I double click on this to edit it, it's already set up as a G-curve with PT data. And there are these 5-axis options down here. The surface scan, that can be a 3-axis thing. Curve scan can be a 3-axis thing, but they also default to 5-axis in this particular case where the curve is a plane and it wraps around on itself, so that we know it's in a pocket or around an edge and not just on a face. So I'm going to choose curve scan. If I simulate this, you'll see that it's respecting some angle for the Revo probe. Where does that come from? And the answer is it's this Revo angle. So if I turn that down to 15 degrees, the other thing I'm going to show you while I'm in here is the speed. Right now it's running at 10% of full speed for scanning. I'm going to bump that up to 40% to speed it up. And now if I simulate this again, you'll both see that the angle is reduced and that it moves faster. Okay, so those are the settings. So that's curve scan. Surface scan. Well, let me talk a bit about, I'm going to go to boundary mode here and pick a point there so that it'll measure around the boundary. And I'm just going to use the aug edit and set the start point, change the start point, because there's this gap here which is good, would cause trouble in real life. Okay, and I had a 50-50 chance of getting the right point. There. So there's a nice, clean, continuous scan around that, and that's a plane. So I'm just going to bump up the speed while I'm thinking about it. So there's these options. I can do a 5-axis scan and move the carriage only in X, move the carriage only in Y or in Z. So with this particular one, moving in Z would be illogical, so you would not use that one. You would either move it in X or Y. I'm going to move it in X to show what that does. So I'm just going to get it so that we can see more of the probe over on this side. So if you watch the carriage, it moves in one direction as that goes around, and the head does all the rest of the work. Eventually, that will wake up for the pH 20, and it'll be doing little taps as it goes around. But the same idea, only the carriage will only move in one direction. Now, the other thing is a surface scan, and I'm just going to hide my segment here. A surface scan currently requires a 3 by something grid of points to work on. And the way you get a grid of points in Checkmate, and we probably want to get these commands I'm going to show you on the menu, there's UV mesh /pound UV mesh. There's a 2-point mode and there's a 4-point mode. The 4-point mode is discussed in that programming of the Blisk video. But let me show you the 2-point mode. So I'm going to pick a UV location and a UV location. And then it's going to do a something by something grid, and it's set up for 3 by 5 because that's what I did last time. It doesn't matter how you answer this. So if I switch that around to a surface scan. Actually, well, first I have to set this to a G-surf to get these options. I'm going to do a CAD along the y-axis first, just to show you the difference in motion here. If I simulate this, then it's following that program path exactly. If I change that to, not that one, this one to a surface scan, and an important setting for the surface scan is the pitch. So how much do I want to step in this direction as I go back and forth? And I'm going to turn that down to something more reasonable, 1. And if I simulate that, then you see it goes back and forth, back and forth. So really, I only needed a 3 by 2 grid, and it would do exactly the same motion. So that's what a surface scan looks like. And it doesn't need to be created with that UV mesh command. You can create it using Checkmate, just standard Checkmate. The thing to know is this is at the center point of 3 points will define the drive path, and then the other 2 define the width of the path and anything to do with the curvature. So if I go to measure surface, and let's say I want to start in this opening and then come down to here, and then I want to go through this thing roughly in that direction, and then come down to this big opening, and then tone it down to go through this opening and that opening, and open it up again. So if I do the necessary things for that, which are to, because if I look at this, there's no surface. I have to make this a surface first, and then I get the surface scan. And in our overall defaults, we probably should change this pitch down to something a lot smaller than 1. This distance 2. This is how often I'll be collecting a point. So every 20th of a millimeter, I'll be collecting a point. In other words, 10 points per millimeter. If I simulate that, then you see it stays perpendicular. And it's doing that 1 millimeter spread. Okay, and now it'll start to do a wider sweep as it gets down to there. Now you notice it's not following these points. When it got to the middle, it was kind of, it's the spine that defines the path. All this defines is the width. So these points could actually be like here and here, and it won't redefine the path. Okay, that direction is defined by the distance, or the direction from this point to this midpoint. These two just define the width. Now, it's important to keep them roughly perpendicular, because if it's a curved surface, then it also defines the curvature. And the Renishaw UCC controller will crap out on the CMM if it's too far off. Now, the other thing you can do is, if I measure a cylinder, and I'm going to pick this guy, and then what I'm going to do is okay, whoops. Yes, I've got to remember to turn that guy off, because bad things happen when you have that turned on and you're trying to do other things. Okay, I'm just trying to get rid of that guy, because what I'm trying to do is shift click and drag this around, and shift click and drag that around, and shift click and drag that around. Because you can set this up as a surface scan feature. So if I set that up to a surface scan and set that pitch to something small like 1, and simulate that path. Okay, now it's going in the direction that that cylinder's programmed. So I need to flip that guy. So there's that curvature I was talking about. Those 3 points define the curvature. That's the up and down movement as it goes sideways. Okay, so that's surface scan. I think that covers pretty much everything that you can play with. But do keep in mind that line scans, arcs and lines, that's 3-axis stuff. The 5-axis stuff is surface scans and these carriage-only movements.